So here we have a problem to use symmetry to evaluate the following definite integral. And the definite integral is the cosine of x, sine of x dx from negative pi over 2 to pi over 2. First of all, in order to use symmetry, in order to evaluate this definite integral, we need to condense what is inside the integral down to only an even function or an odd function. So cosine is an even function and sine is odd. So we don't want both of them in there. However, if we use u substitution, keeping in mind that the derivative of sine is cosine, we can say that u is equal to sine of x, because that gives us a convenient derivative that du would be equal to cosine of x dx. So once we get that derivative, if we solve for our dx, we divide both sides by cosine of x to get du over cosine x is equal to dx. So now subbing in, our sine of x will make u, but our cos of x, we'll just leave that for now because we didn't make the cos of x u. So sine of x, I'll make that u, so times u. Then dx is du over cos x. So that would be du over cos x. And since we did a u substitution, we want to change the limits of our integration. Plugging in negative pi over 2 in for x, that would make sine of negative pi over 2. And using a little unit circle sketch, negative pi over 2 is here, coterminal with 3 pi over 2. And sine is the y coordinate, which this point right here would be 0, negative 1. So this would be negative 1, or when x is negative pi over 2, u would be equal to negative 1. And then for pi over 2, we're up here. And this coordinate is 0, 1. So that would make the sine of pi over 2 to be 1. Okay, simplifying just a bit more, when we have cosine x on top and cosine x on bottom, these can cancel out because they're factors of the whole top and the whole bottom. And that leaves us with the integral from negative 1 to 1 of u du. So now that we've gotten just down to u has an odd power because it has a power of 1, which is an odd number. And since we're going from negative 1 to 1, we can think of that as like negative a to a. Negative a to a of any odd function is equal to 0. So we can use symmetry at that point to say that our evaluation of our definite integral will be equal to 0.